are many formations with multi-zone oil and gas reservoirs that are vertically drilled and stimulated using hydraulic fracturing to optimally recover these hydrocarbons. In this example, we show a well targeting 3 sandstone layers, although this number may vary in different oil and gas plays. Once the drill rig and other infrastructure is in place, a bit mounted on the end of the drill pipe begins drilling the well. The well is initially drilled to a designated distance below the deepest fresh water source near the surface. The pipe and bit are then removed and surface casing is inserted into the hole. The casing is then secured into place by pumping cement through the casing and through the shoe at the bottom of the hole. The cement barrier and steel casing prevent any contamination of freshwater aquifers. Once the casing cement has set, drilling of the intermediate section of the hole continues by drilling through the wiper plug, shoe, and cement at the bottom of the wellbore and on toward the targeted zones. Throughout the drilling, a mixture called mud is pumped down into the well through the drill pipe. The mud serves to keep the drill bit cool. It carries the cuttings to the surface and provides hydrostatic pressure, prohibiting formation fluids from entering the wellbore. As drilling approaches the depth of the first target zone, a technician called a mud logger is brought on location. He analyzes the cuttings, identifying the downhole lithology and any presence of hydrocarbons. As the well is being drilled, he provides real-time information to the company geologist and rig personnel. Once the bottom of the intermediate section is reached, the drill pipe and bit are again removed from the wellbore, and intermediate casing is inserted into the hole and connected to the surface casing. The intermediate casing is also cemented to secure the hole. The drill pipe and bit are again lowered back into the hole and drills through the wiper plug, shoe, and cement. Once total depth is reached, the drill pipe and bit are removed from the wellbore one last time. Next, a logging tool is lowered to the bottom of the well on a wire line. As the tool is pulled back up the entire length of the well, data is gathered to create an electric log. Once the well has been logged and deemed a commercial well, production casing is then inserted. As with the surface and intermediate casing, the production casing is also cemented into the hole. Back on the surface, the drilling rig is no longer needed. A temporary wellhead is installed and the location is prepared for the service crews who will ready the well for production. The first of these steps is to perforate or perf the casing. A perforating gun is lowered by wire line to the lowest of the 3 target zones. An electrical current is sent down the wire line to the perf gun, setting off a charge which shoots holes through the steel casing, cement, and out a short distance into the target formation. The perf gun is then pulled out of the hole. The next step is to hydraulically fracture or frack the zone. Here, sand or other proppants are pumped into the wellbore under extremely high pressure. When the mixture reaches the target zone, the pressure forces it out through the perf holes and out into the sandstone formation, causing it to fracture. This creates a fairway connecting the reservoir to the well and allows the released oil to flow to the wellbore. Next, a bridge plug is placed inside the production casing, isolating the fracked zone. The hydraulic fracture process is then repeated for zones 2 and 1. Now that the frack process is complete, the plugs are drilled out and production tubing is lowered into the wellbore to reach each of the productive zones. Hydrocarbons can now flow simultaneously from each of the zones into the well. The next step is to install a permanent wellhead and other necessary surface equipment. Sometimes a pump jack is used to help bring the oil to the surface. The final step is to install and connect a pipeline to the well that will transport the oil to the nation's pipeline network. Wells that produce from several zones simultaneously result in greater cost efficiency and increased productivity.